Hi everybody, today's lesson is about properties of rational exponents. So the first thing we're going to do is this little warm-up problem, but before we do that, our goal is to simplify variable expressions with rational exponents. So we've seen this before with just numbers, and the only difference today we'll have some variables. So if I'm looking to break down the cube root of 27, remember that 3, that index means 3 of a kind. So I'm looking to break down 27. I'm going to go 9 times 3, and 9 is 3 times 3. So that is one group of 3 with nothing left over. So my answer is just 3. And a rule that could be helpful to remember is that the nth root of x to the nth power equals x. So whatever that root is, so say it was the fourth root of a to the fourth root and the power of 4 really cancel each other out. So the answer here is a. So the first few questions we're going to simplify involving variables. And we're going to assume all variables are positive. So this first one, I'm looking for 3 of a kind. So I'm going to start with the numbers and then I'll move to each variable. So 125 is 25 times 5, and then 25, is 5 times 5. So that is one group of 3 with nothing left over. So I know for sure I have a 5 out in front of that radical and no numbers left underneath. Then I have y to the 6th. Now you can think about this a few different ways. We're looking for 3 of a kind. So I could see, I'm going to start with a y to the 3rd because this is a 3, and remember the cube root of y to the 3rd is going to cancel out. So I'm going to choose 3. I'm going to say, what can I multiply this by to get y to the 6th? Well, that would be another y to the 3rd, because y to the 3rd times y to the 3rd is y to the 6th. And you know, sometimes that's hard to see, but if you think about writing this out, that means y to the 6th is 6 y's, which means I'm looking for how many groups of 3. Well, this one here is y to the 3rd, and this one here is y to the 3rd. That's how I get both of these. But if it helps to write it all out, go ahead. So I'm looking for groups of 3, in which case I have 2 of them. So for each group, I get to bring out one y in front, and nothing is left under the radical, so my radical disappears. And y times y is y squared. So for the final answer, I have 5y squared. And you can think about this y to the 6th in any way you want. You can write it out 6 times, or think about how many groups of 3 you can get, right? 3 goes into 6 2 times. Alrighty. Here I have a rational exponent. So remember, when you have an exponent, everything inside these parentheses is being raised to the 1/2 power. So that's 9 to the 1/2 power times u squared to the 1/2 power times v to the 10th to the 1/2 power. And then, if you remember, power to a power, multiply the powers. But very specifically, this 9 to the 1/2. Remember, 1/2 is also the same as the square root. So the square root of 9 is 3. Then I'm going to multiply my powers. 2 times 1/2 is 1. And 10 times 1/2 is 5. Okay, so 3 times u times v to the 5th. There is another option on how we could solve this. This 1/2 here, like I just said, if you remember, is the same as the square root of 9u squared v to the 10th. And I'm going to go back and do this problem at the end if we have time left over. But you could do it either way. Alrighty, so part C, I have the 4th root of x to the 4th, y to the 8th. So if you remember our properties of radicals, I could write this as the 4th root of x to the 4th and the 4th root of y to the 8th. If you remember a rule from above, right here, anytime we have the nth root of x to the n power, that means x. So the 4th root of x to the 4th is x, and that's because there's 4 inside and I'm looking for 4 of a kind. I have one group. So for y to the 8th, I'm going to break this up, and again, I always start with y to the 4th because I'm looking for 4 of a kind. I want to know how many groups of 4 I can get out of 8. Well, it turns out I can get 2 even groups, right? And again, you could write it all out. Y 8 times, and you have 2 groups, which I have here. So I have y squared. And again, that's because 4 goes into 8 2 times. Alrighty, then part D. Part D is exponents. So if you remember, here we are dividing. So the first thing I'm going to do is 6 divided by 2, and that's 3. This x here doesn't have an exponent, so I'm going to add a 1. And I'm dividing x to the first divided by x to the 1/3. So I need to subtract the exponents. So 1 minus 1/3 is 2/3. Y to the 1/2 is going to stay right where it is. And then I have a negative exponent here, and those need to move to the other side of the fraction. So that becomes z to the 5th over 1. I wrote that line before I realized there was going to be no special denominator. So my final answer, I can't simplify that any further. X to the 2/3, y to the 1/2, z to the 5th. And it's okay to have fractions as your exponents. Just imagine they're regular numbers, and hopefully you'll understand that. Okay. So example number 2, we're going to be writing variable expressions in its simplest form. So we're just going to simplify. And in this case is another example just like the very first one that I did, where we were simplifying. This one didn't have a radical left over, but sometimes there is one. So let's see what happens when we have one. So this, I'm looking for 5 of a kind. So the number 5 is just 5 times 1. So there's nothing I can do there. That is as simple as that goes. So the 5 is going to stay right there. And then again, like I've said a few times, there's a couple different ways you can think about how to approach this problem. You can say, I'm looking for 5. How many groups of 5 do I have in a to the 5th? Well, it's 1, because a times a times a times a times a, I think I counted enough, is a to the 5th, and I'm looking for 5 of a kind. So that is one group that I get to bring out front. And there's nothing left over. And now I'm looking at this b to the 9th. I have 9 of them. How many groups can I get, groups of 5 can I get in 9? Well, the answer is 1. And how many do I have left over? 4, right? 5 goes into 9 one time with a remainder 4. So I'm going to show you again. I'm going to draw this out because maybe this is more helpful for you. I think I counted right. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm looking for groups of 5. So I have one group of 5. That's where I got brought it out front. And I have 4 left over. So 4 has to stay underneath. And then lastly, I have c to the 13th. So 5 goes into 13 2 times, and there are 3 left over. And I'm going to write it out just so you can see what I'm talking about if you don't like to do it in your head. 5, 6, 7, 8, 9, 10, 11, 12, 13. And I hope that everybody's writing this out. So if I have 13 C's and I'm looking for 5, groups of 5, so I've got one group of 5, 2 groups of 5 with 3 left over. So I have 2 brought out front, that's why I have a c squared, and a 3 left over, so c to the 3rd stays underneath. So I'm going to write this a little bit prettier. ABC squared times the 5th root of 5, b to the 4th, c to the 3rd. Alrighty. It's pretty awesome. And the last thing we're going to talk about is adding and subtracting. And this is important because this really just means you get to combine like terms. And what that means is you have to have the exact same variable. So we might have seen something like this where it would be like 5x plus 6x. We're like, yeah, duh, that's 11x. Well, there's no difference when I have the square root of y. And because they're the exact same, I know that 5 plus 6 is 11, but my variable this time is square root of y. And again, this is only when you're adding or subtracting. It's a different type of problem. So part B, I do not have the same radical. So I have to see if I can try to get the same radical. So I'm going to look at these individually and see if I can simplify them. So I'm looking for 3 of a kind in both. But 5 is already as simplified as it's going to go. And then I'm asking you, how many times does 3 go into 5? 1. And how many things do I have left over? I have 2 x's because again 1, 2, 3, 4, 5. I've got 3 with 2 left over, so 1 group on the outside, 2 left over. Then I'm looking at the number 40 here. That's 10 times 4. Actually, I'm going to do this over here. I'm going to look at 40. That's 10 times 4. 10 is 5 times 2, and 4 is 2 times 2. And I'm looking for 3 of a kind. So we have 1 group of 2 and a 5 left over. So that means a 2 is going to go in front and join the x. And the 5x squared is going to stay on the inside. And that's because I can't get a group of 3 if I only have x squared on the inside, right? There's only 2, so I can't get a full group of 3. So now I have the same radical, and it has to be the exact same in order to do this. So I can say 3x minus 2x is 1x times the cube root of 5x squared. And of course you don't need the 1 there, but just in case. So it looks like I am going to quickly go through this last problem with you. So just another reminder on how to do this. I'm looking for 2 of a kind. So 9 is 3 times 3. 3 comes on the outside. U squared, 2 goes into 2 1 time. And then I've got v to the 10th. 2 goes into 10 5 times. And it's a good thing we have the exact same answer. So if you have exponents, feel free to keep with the exponents, but there is, as long as you have these parentheses around the whole thing being raised to the 1/2, you could write it as the square root. So that's it on properties of rational exponents. Write down any questions that you have and be sure to ask them in class.